voucher code is made up of 4 characters. The first is a letter V, X, or P. The second and the third are different digits. The fourth is the units digit of the sum of the second and third digits. How many different voucher codes like this are there? So, if we try and think, so these are, the spaces for the code. So the first letter, the first code is a letter, so it can be V, it can be X, or it can be P. So that is 3 ways. You can either have a VX, V, or an X, or a P. The second one is numbers, is a digit. So it can be anything from 0 to 9. So you can have any digit from 0 to 9. And the third one is a different digit. So it's not one of the digits you have picked for the second place. So the third place, so if you have picked a 0, you have to pick a 1. So and so on. So it can be anything from 0 to 9, but it just has to be different. So 0 to 9, you can fill it in 10 ways. And because if you have picked one of the digits for the second place, you cannot repeat it for the third place. So the third place, you can fill that in 9 ways. And for the fourth place, it's a bit tricky because what they're saying is the units digit is the sum of the second and third digits. So if you have picked a 0 and then a 9, is the sum is 9, so then it would be a 9. So it's dependent on the second and the third place digits. If you had a, say, 9 and then an 8, then your total would be 17 and the units digit would be 7. So it's because it's very it doesn't change, it doesn't there's no arrangement possible because it doesn't change the code. You can't have a different, with a say you've picked V9 and 8, then you cannot have anything else in the fourth place other than a 7. So you will have a 7. So if you have picked, for instance, if you have picked V and then 8 and then 9, you would again have a 7. So it doesn't give you any option, so to say. So it doesn't do anything. So we're not interested in what happens in the fourth place. So we don't. It doesn't matter. So all we want to do is, when we are counting, we ignore it. We don't count it. So we ignore it, and then what we do is only the first 3 places matter. So the total number of possibilities, different codes possible, would be 3 times 10 times 9, and that is 270. So for the fourth place, I can say no arrangements possible. So the different codes possible would only be 3 times 10 times 9 and 270. So the answer is 270.